Scrap Team on air, and welcome back for some more crazy engineering. Well, today we're gonna speak about rails and especially about building them beautiful monorail. Let's start from some spotlight of problems that we have with this design, with kinda hinge-based design. Firstly, you'd better have this hinge on, because they can go crazy like this one. You see that current angle, it's more than 300, but this hinge kinda limited to these limits, so yeah, that should be a huge pain in this, and the only stuff to do with that is to kinda rebuild it completely, because otherwise it's not gonna work. Let me do that real quick, because we need that guy. Add hinge head, yep, and oh, it's not gonna work even like that. Okie dokie, let's replace the hinge completely. So it was something about 10 degree, but the question is in which direction? Yep, in a low direction, which means we're gonna go 10 here and my goodness, 0 here. Yep, now we can bend it and finally build our rails. Yeah, that's the problem with this design, that we're gonna have a lot and every time, so that's why I don't like this design too much. Also, keeping them on, you're gonna drain your power, because each of these hinges consumes something like 2000 watts. Also, you're gonna have a lot of batteries because of that gaps. Those two guys are not connected, which means this guy is not powered right now because there is no battery, and oh, there is a battery, but you get the idea. If I remove this battery and slap something like a button, for example, yeah, this guy, you see, it's offline. We don't have an energy here, and that's not great. That's not great at all. So let's slap it back. We're gonna need it. Okay, other problems with the design is that it's actually not too stable. As you see, those hinges can go crazy and kind of accept some weird angles, and also game doesn't like a lot of subgrids, a lot of dynamic subgrids. Of course, we can kinda make it static, but if two static grids are connected using hinge, rotor, or piston, game physics doesn't like that at all. So how I propose to solve that? In a ideal case, we wanna have a grid powered by its own. I mean, we wanna avoid placing battery on each part. What can help us with that? Connecting these grids somehow. And in terms of connecting them, we have now this amazing block that actually, yeah, give us something like that. Why this block better than regular connector? Because it's kinda square and we have a lot less gaps. With that said, how we actually gonna build next part of that rail in order to bend them? Well, it depends on bend direction. If you wanna bend the rails horizontally, you're gonna go and place some blocks on top of it, and then we're gonna place hinge in a horizontal plane, of course. Then we're gonna need few strange stuff. Firstly, rotor placed horizontally, and you wanna lock it immediately. We're not gonna spin the rotor. Not gonna spin it ever. Yeah, I gonna tell you why a little bit later. And the second rotor we need in this direction. Lock it also. We're not gonna spin it also. Well, now we are ready to place blocks to the bottom to actually build our rails. Something like this, great. Something like that. and one more with connector itself. So we're gonna go grab the connector. Yeah, you can probably use these connectors, it's fine, but you just should be ready that your wheel's gonna bounce a lot on them. So I personally prefer use these connectors. Let me place it in the right direction, something like that. Yep. As you see, it can be connected, but it's hugely misaligned. And that's gonna be a real pain to drive on that stuff. So this why we need these rotors. Let me actually give it a slight angle. Yes, oh, let's go different direction. Yeah, not that much angle, something like 5, oh my goodness, what's wrong with me today? Yeah, something like 5 degrees should be okay. Now we need to align this stuff, and to do that we have this rotor. And it kinda gives us an ability to use its displacement to make it more or less aligned. And this rotor we need to actually reduce this huge gap that we have, but first I wanna place a block, something like that, to fill this gap. Yeah, that should be it, you know. So what we're gonna do with this guy is also use a displacement to actually connect them like that. Yeah, all the things that we need to do now is switch lock, and we can get rid of all that crap that actually drains our battery and provides a lot of pain in this. And as you see, it holds and doesn't use any power, and actually it kinda transfers power between these guys. So if we slap that button back, as you see, it's online, it's working, not a problem at all. Yeah, with that said, how, let's actually get it a little bit longer to actually drive that stuff with our train and look how it works in terms of driving. I believe that this angle should be alright. So for that part you see that it works, and now we come into this part where it drives just without any issues. Just without any issues, because this turn is really smooth. We have kinda a little bit of misalignment here, but it's nothing compared to what we had before. Now the question is how to bend that stuff vertically. In this case, we're gonna go from the side. And why we're actually gonna go from the side? Because you kinda wanna have that hinge on a plane of bending, and to reduce usage of these rotors. Well, in this case, we wanna have rotor in this position. Oh, come on, you can be placed like this. I know. No? What? What's wrong with that part? Alrighty, doesn't matter. Actually, we can place it like this. Not a big deal. Yep, and the second rotor, just as always, to the front. And now we can, yeah, first things first, we need to actually lock them, because we don't want any accidental spins or stuff like that. So now we can go here and simply build our rails. Yeah, something like that. Of course, we're gonna need connectors on both sides, so let's do that. Connector here. I'd like to have it in this direction, and connector here. Yep, it is like we want it. Oopsie daisy, I placed this guy in a wrong direction. Let me quickly rebuild that stuff. Alrighty, now we have right hinge here, and we can kind of move it a little bit to up. Yep. Nope. like that. Yeah, 5 degrees should be all right. As you see, we have huge misalignment here, and of course we're gonna compensate it with that rotor. All the stuff that we need to do is move it all the way down like that. Now it's much more smooth, and of course in this case we're gonna refill all this gap like that, and we can slightly offset it back. Yep, exactly like this. So now we can just switch the lock and get rid of all that mess because we don't need it anymore. Yeah. Of course, game gonna spawn something while I trying to record this video. Well, as you see, this bend is really smooth and it's totally fine. Let me actually repeat it on that part, just to show you how it drives over. Alrighty, we have that part here. Let's make it just a little bit longer to be able to drive through. And oopsie daisy, and we're gonna test that. Test that connection. Alrighty. So for this stuff nothing changed, and for this stuff you see no weird wiggles, nothing like this. It just drives straight through that without any problems. What other advantages this stuff has is that you actually can easily transform it from dynamic grid to a static grid. So what you want to do in this case is go here, place key and convert to the station, and now you can nice and easy connect it to the ground like that, and I'm not gonna go fancy today, I'm gonna go just like this. Yep. And it's still powered, it's still not gonna be destroyed by a garbage collector, but now it's static, and that means that it's gonna drain a lot less PC resources, a lot more stable and stuff like that, and you can do that for each section without any problems. Also, as you probably noticed, it might be converted to something interesting. Like, for example, conveyor. It can connect all the stuff with conveyors and be still operable without any problems. Yeah, that's really nice design. What also worth saying here is I not recommend it to try to bend this stuff in two directions simultaneously. I mean horizontally and vertically over one joint, because that's gonna be a huge problem. Someday maybe I'm gonna design one block rail, and those rail probably might be actually bent in two planes simultaneously, but that's gonna be a little bit later. If you wanna see that, let me know in the comments, because I'm about to take a break and design something else, because I become fed up with these rails already for a little bit. Okay, at this particular point, this video had to be on air something like 3 weeks ago. But then I get to some silly engineering stuff. If a task can be automated, an engineer will do that. Even if it's a one-time job, even if automation takes months, but the task only takes hours. So I asked the question, can it be automated? And then I found an answer. Well, the short answer is yes, and it takes that much tries, that much attempts to actually do that. Let's probably start with the first try, with the first idea, with the first design, and it's kinda following realistic logic. You see, the thing is that in reality, all that pieces, all that blocks are built on a factory and then just mounted with rail laying machine. But I kinda thought, why can't we carry the factory with us? So that's why this machine has its kind of factory on a top. Let me actually demonstrate you how it works. We're gonna turn off this block, get rid of it because we don't need it, and turn our stuff back to the factory. Actually, the most realistic approach you can find in latest, not latest, but one of the latest episode of Engineered Coffee. He made it really in most realistic approach possible. Alrighty, with that said, while welders is active, all that stuff gonna be welded. The only thing that they're in incorrect position, so we're gonna reverse them now to get him an ability to weld that stuff totally, because it's gonna be welded from this position, from the only block where it might be attached. So as soon as they all the way back, we can send them back to the front. Yeah, to kind of weld that stuff. So let's do that real quick. And yeah, there is some automation to some extent, but I clearly can't remind how to use it, because there is a lot of stuff, you know, a lot of stages and stuff like that. And that was the first attempt, so that was something like 2 weeks ago, maybe even more, so yeah. Sorry, I can't remember that. We're gonna go silly way. Then this rotor just turns and places this stuff in a correct position, which means we're gonna be able to attach it and then move further. Yeah, as you see, we have a lot of welders all around, because with that approach... Oh, we actually missed the block. Yeah, we're missing the block. We're missing the blocks all the time, and I don't like that. Yeah, and it goes much further than it should because of something broken, but that doesn't matter. What matters though, that there is lack of one axis shift, one axis offset piston probably. As you see, we have vertical guy, we have forward guy, but we don't have a horizontal guy, and that's not great when we're trying to kind of bed our rails horizontally. Okay, anyways, where is an idea that we're gonna have welding mechanism, we're gonna have mounting mechanism, and we need something to walk further. And in this particular case, it's failed on a walking further, because we need actually 3 pistons, and I'm gonna describe you why in a minute. Okay, then I switched to not that. That was the worst design actually, because with all that hinges, it's just hilariously difficult to place it, to actually position it correctly. Alrighty. Then I go to this design, which is actually not bad, and I believe that this one even works, but I kinda don't wanna check that, because when time flies, you know, it's fine to forget a lot of things. And further and further and further, I even try with longer sections, but it became complete disaster because of all that. The larger pieces you have, the more wigglier construction became, even if you use that interior tensor stuff. It doesn't help a lot. But if I'm not mistaken, yeah, at least walking mechanism implemented correctly here. We have two guys on the back and one guy on the front to actually work correctly. Well, the principle. You need some welders to obviously weld further part. You need an ability to move them, and all that welders with part and with all the stuff should be after this hinge to actually show the position. I mean, to actually bend rails, yeah, because when it's on a further position, you need to switch to it to basically move all the back. On the middle side, you need the rotor to kind of keep previous direction to remove all the extras that we have here. And speaking about extras, it's these heads, rotor heads, which used to basically walk further, and it's where it is actually. Oh, here it is. Merge blocks that holds piece while it's not locked to the main railway. Yeah, well, that huge pass that one of our viewers asked me to build is actually built using one of these machines. So the first version, to be honest, that's why we have not too smooth stuff. Unfortunately, as you see, we have a lot of gaps like this, which is not great, which not help us driving smoothly. Version 2 improved a lot, but first let me actually show you the principle here. There we still have, only two offset pistons, that's why those rails are not that smooth, and that design is typically and even probably totally okay, you know, but I kinda don't like all that pistons sticking around with all that empty space here. So that's why this guy much more compact in terms of height. But what's similar here is control room, because I really fell in love with these control panels built like this, as a small grid with a lot of buttons, with a lot of stuff. And actually kudos to Engineered Coffee, because I seeing that idea first time in his videos. Well, what abilities it provides us? Firstly, to select an angle for the direction or for the altitude, and select amount of pieces that we actually wanna build, up to 10 pieces on each step. On each, not step, batch, yeah. Well, something like that. And this iterator design is fairly interesting idea of usage timers. And as you see, we have 1, 2, 3, 4 servers here that actually operate all that automation that we have here. But I'd better show you the principle, how it works on version 2, because firstly, this version 2 is available on Steam, so go check that out. And secondly, because it's a little bit more improved. The same server room on the top, kinda protected from rain and dust, you know. Why it's improved, why I'm saying that it's improved. Firstly, I added that indicator lights that show in which direction it's currently configured, so we can go with all that stuff. And now I probably wanna, let me see. Yeah, we built 2 pieces going up, so it's gonna be nice to build 2 pieces going down. Like that, and we can select amount, and all the things that we need to do is launch it. Now, how it actually works. As you see, firstly, it's position all the welding part in a correct position. It's a little bit wiggly, but considering kind of space engineers physics, I believe that's fine. With that piece size, it's actually not that wiggly, it's not that bad, but it still has some small wiggly. Alrighty, when it's welded, it's gonna be switched to the front connector and attached here and deattached there, and a lot of stuff like turning off projector, things like that, and cleaning phase starts. As you see, we have two grinders on its back. They actually here to get rid of all the extras that we have. They moves really slow because this guy barely touches this block, and it's needed to not grind other blocks, especially when we have other angles, and believe me, that's important. It's better go slowly than have issues. Then step starts. Now only front piston holds us, and we're gonna go to that piston. Now all the constructions go to the ready position when welders all the way to the back, and middle piston is attached there. That's gonna take time, so let me skip it for you. As soon as it gets to this point, it comes to the second piece. Yeah, as you see, positioning, now welding, and all the steps that you already seen. All these panels are pure decoration. They're not needed, they shouldn't be here, and I mean, they're not required to be here, they could be removed. I just edited them because, you know, to have that stuff a little bit more designed. And all that wiggles kind of disappear as soon as this connector connected, and it goes further and stuff like that. Well, in this case, yeah, we have really smooth result. As you see, almost no bumps in both planes, both vertical and horizontal. This guy is much better. Yeah. The only last question that we should observe is probably how to build arrows, because that's a really interesting question. In this case, we have an arrow that built with kind of this approach. We have two hinges on the back, and I especially left two here because I wanted kinda check how it behave, and it behaved perfectly. As you see, if I stand on it, you see that there is almost no movement on that part, and that's because we actually connected here through the piston, but still. Why do we need this piston? As I previously described, it's a big problem with these connections, that actually there is a different lengths between these blocks. In this case, it's a little bit farther than one block. In this case, it's exactly one block, if I'm not mistaken. And also, as you see, distance here changes, so to maintain both of these distances, we need that piston that actually works kinda like this, not a big deal. And this guy actually, as you see in a chat, has a broadcast controller on it and antenna to actually tell you when it's finished work and ready to move further. Well, yeah, you can build it like this. I covered this with some panels. Obviously, you can add more panels here if you wish. That's kind of not a big deal at all. Actually, let me add them. Maybe that's gonna be even better. Panels. I'm gonna go to the standard panel, like that, and probably that should be That should be really nice. Oh, this guy might be impediment. Yeah, let's get rid of that one. Alrighty, now we can switch. Yep, the whole construction retracts. Goes to the desired position. And extends while it can connect. Yep, now it's connected and it's totally ready to drive through it. Let's see how it drives over that thing. Oh, come on. Yep. You know, not bad considering its design, considering I being lazy, and it has really sharp angles on both sides. It's not bad at all. Okie dokie. And yeah, by the way, I added some logic here that gives us an ability to simply press one button and all that stuff gonna run by itself. Well, with that said, just as always, look to the Steam Workshop, test it, drive it, and let me know what do you think about that. If you think that's at least amusing, maybe even a little bit useful, smash that like button, and if you wanna see more content like this, consider subscribing. That's might worth it. With that said, thank you very much and see you next time. Bye bye, folks.